Hi, hello, welcome. Long time no see. I have been off for quite a while as I'm working on some of the other projects, working on automators, working on just web. There's a lot of things that I would like to share, but those things are a lot more complicated. And yeah, of course, the module resolution for TypeScript that also took me a couple weeks to do. So hopefully in the future I can get myself together to get some videos about that. I think you will like it. So for today, what we are going to do is just have some fun, and we will implement a type that's doing the IndexAt. And what it is about finding the resolving the type at an array. And it should be a pretty simple one to do. And for those who want to learn about TypeScript, doing type level programming, I think it's a good introduction. So without further ado, let's get started. So over here, this is the ArrayPlus project, and I have already reorganized the code a little bit for the new version. Just yesterday, I released the ArrayPlus 6.0, and one of the new or two of the new functions are this add function and the concat. Right. Well, the concat is actually already exists. I just move it around to make it under this ArrayPlus namespace. So what happened is, well, before I talk about it, because this is just code, right? And so in the new version of ArrayPlus, besides the code that you will able to, where am I going? Say over here, right? Besides, you were able to get the use the functions like you normally do, or the type you normally do, right? Say over here, this is from the index, right? So when you import ArrayPlus, you were able to use the concat directly. But besides that, I'm also start exposing them inside a namespace object. So say for example here, I thought I have it already. So since it's not, let's add that. So for concat, it will also be available over here under this ArrayPlus. Because the reason I'm doing that is so that for the ArrayPlus that's getting more and more types into it, and I'm planning to add more. And the top level namespace, quote so to speak, will be congested, and the name of the type or the function will become harder and harder to define or consume, right? Because there will be name collisions, and when you look at a functions or a type, you don't know how what does it apply to. So I decided to start adding or re-exposing them through a namespace, right? This is something similar to, say, for example, the TS2 belt, which is also an excellent library. And over there is exposing the types under different namespace, right? A for L, I think L for list, and it also has export the namespace list itself as an alias. So this is one way to do it, and just think about in OO, right? So it is pretty easy or natural to do. So over here, let me just add the test. So when I do the concat of 1, 2, 3, and 4, I will get 1, 2, 3, 4, right? Like that. Right. So again, the function is already exposed, or the type is already exposed at the top level, but I'm just exposing it again under this ArrayPlus. So with that, well, let me first add that. P npm cs Oh, hey, what's going on? So slow. Okay, all right. Well, should it be a patch? It's okay. Export concat under ArrayPlus. Okay, like this. Right, so let's say, yeah, let's add it as a minor feature. Save this, add array. Hey, hi, Haruna. Hi, yes, I didn't see your message. Yeah, thank you. Yeah, hope you will enjoy it. So concat to ArrayPlus. Right, so doing that. All right, so now let's get to the meat of this this stream, which is adding the index. Right, so here, let me think. I was thinking about doing this in this file, but actually no. IndexAt and .ts. So export type IndexAt, right? And then what happened is it will take an array, right? So array of unknown, and then it will take a number, right? So and extends and then number, right? And then it equals to something. We don't care what it is at the moment, and adds the virtue of TDD, right? So I want to add the test first. TS. So another thing you notice right now, I recently updated the TypeScript guideline, and I renamed it to TypeScript Black Book. And over there, I have a recommendation on how to structure the, how to name your files and folders. And if you are interested, you can go and check that out. And this is what I'm doing nowadays to keep things nice and tidy. So we are doing this IndexAt. Right, so over here, what should it do? So returns type of the element at index, say index 0. Let's start with that first, the easiest, most degenerate case. Right, so so the type R equals to IndexAt, right? So say 1, 2, 3, right? And then I want to get a 0, and I want to say its type equals it's a true equals the type R. I want it to equals to 1. Okay, of course, right now this is not working, and that's the whole point, right? During TTD, you want to first make sure that it failed, and then fixing it. And so another thing why I am creating this as a separate file is that over here, I was planning to have more types into the same file. It is a little bit easier to handle, and then also, about the organization, that the file name is describe one category, right? It's in this case in an array, right? So for the array, I could have multiple types over there, and that's fine, right? But for this ArrayAt, because one of the reasons in long term, what I'm going to do with TypePlus is that I want to expose the types that's mimic the functionality that you get from array. Say, for example, I just implement the add, I have the concat, and then the copy within will be next. But actually, before that, I was trying to do that a little bit. And what happened is, before I do that, I actually need to do something like this slice, because the copy within is actually a superset or a more complex implementation of slice. So I will be implementing that first. But The thing is, when I'm implementing slice or implementing copy within, say for example, for the copy within, it accepts the target, the start, and the end, and it's all of this value can be negative, right? So that's why I want to have this IndexAt function so that I can handle the negative values. Over here, for the add function, I already handled it. Is right here, and we will get into it in a little bit. But since there are a lot more functions, we'll be using that feature. So I'm going to extract that and put that in the ArrayAt. And for this ArrayAt, since it's not commonly used, right? So I don't feel like I want to expose it at the very top level. So meaning in the index, as mentioned over here, I was exposing the array, right? Over here, you can see that. And by the way, this is a new syntax, right? The export type star. This is a new syntax support by TypeScript 5.0. It just released yesterday. So, so yeah, this is a lot nicer than I have to describe all of this one by one. And actually let's do that. Let's change all this, since I will be doing changing all this. Is there an easier way to do? There you go. All right, let's do it like that. The literal array, those is fine. Those are fine. And then let me check this one in. Right. So fix, use. This is really not fix. It's a refactor. And I use export. All right, another change. Okay, so that's fine. So now over here, so that explains what and why we are doing this. And because this is really internal, but still in certain use case, I want to expose it. So I want to expose it over here. Right. So that's why I want to do this export type star from array index at. Okay, so with that, I will be able to use it over here. So of course, I will be do that in a bit, right? First, let's focus on getting the test to pass. So now over here, so what should I do? The easiest way to pass, just return 1, right? So you can see that return 1, it passed. But of course, that's not really beneficial. And so the easier way to do is, well, the better way to do is say return a of n, right? So then this will pass, and then the next one is you can generalize this by saying returns the type of the element for positive indexes. Right. So basically it's really the same thing. And for this, I'm just lazy to do the thing. Change this over here, doing this, and then let's do that. Right. So like that. And I can say if this 0, 1, and 2, and so this is 1, 2, 3, right? Simple. So then, what happens when it is beyond the number, right? So what you can see is, say for example, if it is a actual array, right? And then you try to do if you try to do index like 5 like this, right? So console.log over there, Quokka, start on the current file. Oh, I changed the system again. No, that doesn't work. So hold on a second. Run code. Where is it? Yeah, I think let me reinstall this. Yeah, for the Quaker, I was changing some configuration, so it doesn't run at the moment. So if I run this, yes, no, it's not recognized. Damn it. Okay, an even easier thing. Oh, you won't able to see it. npm add install group yes node to see if that works. Was really license. Yes, switch over, use the community for now. I'm so stupid. Right, so yeah, you can see that this is returning undefined, right? When it is out of scope. With that, you return free, right? This return undefined, right? So we want to probably mimic the same case, right? So, but first we add the test, right? Returns. So the type, should the type be undefined? Very much yes. Return undefined when index is out of range, right? When I'm implementing this, one thing I would think about is, should it be whenever it comes to undefined, right? Should it be undefined? Should it be null? Probably not. Should be void? Should it be never, right? But since at the value scope is returning undefined, is fine to return undefined, right? Which it does, right? So 3 is undefined. Let's say -1 is not undefined, right? So, but that is something that we will going to fix, right? So -4, let's do that. Let's do that a little bit, because it's time to get to something more interesting, right? About negative number, right? So it how do I describe it over here? Negative. I didn't describe it at all. So I just okay, if I didn't describe it, why not? Right. Do the same thing over here, and then say -0. It will be still 0, which is 1, which is fine. So, and then -1, this should be 3, right? Just like it over here. And then when it is -2, it should be 2, like that. Right, so that is not working, obviously, because the code is just really a nothing burger over here right now, right? So the way what we can do is this. Well, instead of bore you to death in figuring out how to implement it, I already have the implementation, right? So that. See, let's get it from the numbers, separate it. Let's do it like that. There you go. Right, and to make it a little bit easier to read, let me put it top to bottom like this for a moment to explain what they do. And with that, let's say type. Okay. So this negative, I already implemented. This implementation actually mostly comes from Typefast. Right, they have some negative, have some implementation, and this is basically this is straight copy from Typefast, and I think it is useful. And the only difference between my implementation and the Typefast implementation is I'm supporting all this special handling that allows you to allow the type to be a lot more flexible and do things, much more interesting thing, in my opinion. So over here, the negative number is just check if this negative number, and so it have two variants, two ways to use it. One is as a filter. In the TypePlus README, I explain what filters versus logical means, and maybe later on I would change the name of it if it's not clear. But for now, I'm still calling it filter. So it's when the value is true, it just return the type back. If not, it will return never. That's what filters mean. So in this case, what we will get is the, where am I? Here. Okay. Oh, ArrayAt here. So when the value n is negative, then I go ahead and go there and get the, oh, hold on a second. I do it wrong completely. IndexAt. Yeah, what the hell I'm doing? I was re-implementing index. I'm re-implementing add. That is not what I want at all. Right, so that's why it's good to talk it out and describe it. So this is no, -1, this will be 2, this -2, this will be 1. That's what I want. Come on. So the IndexAt, what it does, right? Well, that means it is a good time to start adding some description, right? Because I get myself confused also. So over here, yeah, let's close this so we get more space for now. So let's first describe exactly what it does. Get the normalized index value index to access the element of an array or tuple. Okay, that's what it do. So here I can add an example, right? So import type in this case it will be ArrayPlus, as I mentioned. It will be under there. So from TypePlus and the type result, this will be ArrayPlus.IndexAt, right? So 1, 1, 2, 3, and then if I want to say -1, right, then I will get 1, right? So let's keep it with like that first, right? That's what I want to do. So now go back over here. All of this is completely wrong. So essentially, what I want to do is I want to first get the absolute value of the value n. Well, actually, no. Yeah, well, actually, yes and no. Let me just go ahead and implement the whole thing. So when it is negative, right, which is still okay, then I want to say over here, if let's solve the positive case first, right? If it is positive, then I want to further check that if the number is greater than, I can do it either way. If the length is greater than the n, because I know in the else case is positive, right? If it is greater than that, is greater than that, so then that is okay. Then I will just return n, right? Else, if not, I will return undefined. Right? Supposedly, that's how it should work. However, the greater than was not supporting that functionality yet. So I would say extends true. Right? If it is true, then it will return n, right? Yeah, so what happened is this. When it is free, it should still be undefined, right? So if n if the length of the array is the same as n, right, then it is actually out of range, right? If it is true, if it is greater than this, not out of range. If not, it is undefined. So now you can see that this is fixed. And if this not, then it just return n, right? So then now here, this, if it is negative, right? So if it is negative, then what I want is this. So this is the actual value. There you go. Right, so that's what I want. So here, to explain this a little bit, what this means is I basically having the length of the array minus the value n, right, the index n. And the reason I have to do this ABS because the subtract doesn't work with negative number yet when I was implementing it. So it only worked with positive number. So that's why we have this issue. So then what if it is larger, right? So if it is -3, right? So when we have this, it should be returning negative, should be returning undefined also. So what I can do is, let's do it again. Right, so console log 123.add, right, -3, -2 is 2, -3 is, yeah, so -3 is would be 1, right? And then if -4, then it would be undefined, right? And yeah, so meaning here, when it is -3, this should be 0, right? So that is fine. However, if it is yep, that's where there's the -1 issue. So -3 is 0, which is fine because -1 is getting the last index. So -2 is here, -3 is here, is -4. That's when it's get out of range. Yeah, so that's why we need testing. So what we can do is, because this is 4 and the length is 3, so we can say if the ABS at the absolute value of n is greater than a length. Right? If that is the case, extends true, then I get undefined. If not, then it's good. There you go. So now this all pass. Okay. So I think that's all the tests I need, right? So just double check. I have all these tests, just testing one case. Positive for positive index, yeah, it's not really positive anymore. So we can separate it. Separate that for negative indexes. Right, so -0 is still 0, is practically neither here or there, but it's okay. We could just add it in. So 0, 0, 2, 1, 1, 2, 3, that's good. And this is out of range, this is out of range, and we're good. We didn't miss any case, right? Of course, we will say beta 1, right? What will happen when that is that. So yeah, so that is a good point. So it accepts only integer. We already tested the integer case. So let's say IndexAt type R equals to IndexAt 1, 2, 3, and say 1.1, right? What will happen? This will get 1.1. Yeah, and which is not what we want, right? We want it to fail. So what we can see, what we can do is this TS expect error only suppress the error. It doesn't check it otherwise. Well, let's implement it. The integer type is a generic type, so I cannot use it. Well, no, I can. What am I talking about? Any. In case I have to use any. Yeah, that doesn't work. That doesn't work. So how do I prevent this from happening? This, even though it extends, the other way is a superset, so I cannot really do it like this. So I can. Yeah, I can do this. So the integer also, again, is different than the implementation from typefast. It supports additional logic, right? So that's what I'm going to do here. If it is integer, then I will do this, right? If it is not an integer, then I will return never. right, to signal something is wrong. True. Well, no, not. Does that work? Yes, it does work. Although there is a better way now. Also, I added in yesterday, which is never. Right, this should be never. There you go. Okay, so then I can rename this to saying that returns never if n is not an integer. Okay, so that's what you can do. So yeah, now that looks fine. Right, and here this doesn't look good. Is there a way to flip it to make it, you know, a little bit more organized? In the future, I probably need to readjust the greater than type to make it a little bit nicer. But right now it's suffice. Right. But obviously, if I change this, you know, there will be the equal case, you know, so the flip won't work. I can have, say, less than or equal to, but, you know, this should be okay. You know, remember for the type level, the greater than, you know, that's the equality. The equality will go for the other side, so it's not like you know, there's also always the equal case that you need to think about. Anyway, now finally, this works. That's all what we need. So let's do the final cleanup with that. So any other interesting case? Yeah, let's say 3. This will be undefined. Right. Let's just do the normal case too. No. This is wrong. So -1, it will return 3, and then 1, it will return 1. And to make this less confusing, right? So let's use A, B, C instead. Like that. So 1, 1, 1, -1 will return 3, return this location. So well, no. -1 will be 2. Yeah, what am I doing? So 2. And then if there's 1, then it will still return 1, right? And when it is 3, well, let's make it 0 will be 0. Right, and then let's move it over here like this to make it more easier to read. And when it's 3, meaning it's out of range, it will get undefined, right? The same thing for -4, right? Will be undefined. Since this a little bit convoluted, right? Let's do it like that to make sure this looks good. So you can see that all of the examples over here, and that's it. So now let's wrap up. So as you can see, we have implemented the IndexAt function, and it is a little bit more complicated than you might originally imagine. Well, although the ABS stuff and all this, you know, when you go into it, could be a little bit overwhelming at the beginning, especially this greater than, and because the greater than stuff is using the special feature in Type Plus. That's why you're able to do actual arithmetics instead of using the string comparison. And with that, then this greater than those digits system, again, that's something that I should talk about in the future. That's what make all this possible. All right, so anyway, so that is the implementation. So one last thing is having, you know, getting, yeah, let's get this one, this example over here. Is type dot equal, that will equal to 2 and true. All right, let's just, for the sake of it, for the shakes, there you go. So the very last things, since this is an internal type, well, why not? Still going to talk about it, a array plus. So here, I'm going to say array plus dot indexat an, right? Gets the normalized index for a. Okay, there you go. So PMPM CS minor, right? So add array plus index at feature at array plus index at. And everything looks good. There you go. The last thing is to publish it. So that's it. So, and that's it for this session. Hope you find this interesting. Hope you enjoyed it and hope you learned something. And with that, we will see you next time.